Lesson 8-9, perfect squares. So our objective today is to factor perfect square trinomials and to solve equations involving perfect squares. And you see the standards listed there, Algebra 1, 6, 7, 8, 2, 8, 3. I am going to add an objective. It's basically an overall review of all factoring. That's what we're going to do. So basically by the end of this, you should be able to factor any kind of quadratic that we have. So let's look at what we're talking about when we say perfect squares and trinomials. Basically, when we did the lesson on multiplying special products, we did these a plus b squared, and we said square the first term, multiply the two terms and double it, and square the last term. That was going to be a shortcut that I showed you. And the same thing was true if it was a minus b squared. You squared the first term, you multiplied the two and double it, and then squared the last term. So basically that was the shortcut. But I also advised you, if you couldn't remember that, then just remember it's those binomials times themselves and FOIL. Okay, and that is still true. I still believe that that's what you should do. But now I'm going to tell you a shortcut to recognizing if something is a perfect square trinomial and trying to factor it. Again, if you don't remember this shortcut, you can still write your two parentheses down and factor the way that we've done this week. Okay? You still can do that. But this is if you want to do a shortcut. So here's what you do. You ask yourself three questions. First question, is the first term a perfect square? If it is yes, you write down its square root. Question 2, is the last term a perfect square? If it is, you write down its square root. Then your last question is the middle term 2 times the square root of a squared times the square root of b squared? And if it is, if all three of those are yes, it is a perfect square trinomial, and you can factor it as such. It's a really quick factoring after you ask yourself those three questions. So let's go right to an example then to see what we're talking about here. Is it a perfect square? So 25x squared minus 30x plus 9. Okay, so I'm going to do it like this. Question 1. Is 25x squared a perfect square?
Yes.
Yes. What is its square root? 5x. So write down 5x off to the side. Question 2. Is 9 a perfect square?
Yes.
Yes. What is its square root?
3.
Question 3. Is the middle term 2 times 5x times 3? 2 times 5x is 10x. 10x times 3 is 30x. So the answer is yes. Yes. We answered yes to all of those. So here's how you do this. You only write one set of parentheses. You write the answer to 1 first. You write the answer to 2 second. And then you look at this sign. That's what you put in the middle, and it's squared. 25x squared minus 30x plus 9 was a perfect square trinomial, and when we factor it, you would get 5x minus 3 times 5x minus 3. We just did it in a shortcut method. Okay? Question?
Would it be the same as the last term was a negative?
No, the last term, if the last term was negative 9, is negative 9 a perfect square? No. So don't be tricked by that. If the last term is negative 9, that is not a perfect square, so that would not work. What?
Negative 9 not be a perfect square.
What two numbers multiply itself by itself gives you a negative 9?
Oh.
Nothing. So that is not a perfect square. perfect squares have to be positive. Okay? All right, let's look at example B. Okay? Question 1. Is 49y squared a perfect square?
Yes.
What is its square root? 7y. Okay? Question 2. Is 36 a perfect square? Yes. What is its square root? 6. Question 3. Is the middle term 2 times 7y times 6?
No.
What is 2 times 7y?
14.
14y, and 14y times 6,
84y.
84y. Well, we wanted it to be 42, so the answer is no. It's not a perfect square. No, not a perfect square. So you're going to ask yourself those 3 questions, and if it works out, you can factor it with the shortcut. All right. Questions about perfect squares. That is just one of those shortcuts I'm showing you. If you can't keep track of that, then put your parentheses out there and factor and do your test and outer inner and all that. I'm going to tell you, you can do it. You would just end up with, on this one, 5x minus 3 and 5x minus 3. And then you'd say, oh, darn, that was a perfect square trinomial. I could have done it a little quicker the other way. But it's the same thing. You can still factor it that way. Questions about that? All right, we're going to do an overall review of all factoring steps. This is what you should do every time you're given a quadratic. And remember, a quadratic has a squared term, or anytime you're asked to factor anything. These are the steps you should follow. Step number 1, always factor out the greatest common factor. Always look for greatest common factors to factor out. That always simplifies your problem. Step 2, if it is a binomial, after step 1, the only other thing you can do with a binomial is check to see if it's a difference of squares, a squared minus b squared. If it is not, you would be done. If it is not a squared minus b squared, a difference of squares, then you would stop after step 1. Okay? If it is the difference of squares, well, then you factor like we did yesterday. Next, if it would be a trinomial, I would check for perfect squares first because it is a shortcut. But if it is not a perfect square, then you have to do the trial and error factoring that we've done over the last few days. And then finally, number 4, if there were 4 terms, you would have to do factor by grouping. Split it in half and factor out from each half and see if what you would have in parentheses would be the same, and then go from there. So this is the overall factoring steps. Most important, always do GCF, and then each of those steps 2, 3, and 4 addresses for 2 terms, 3 terms, 4 terms, what you should do. So what's going to happen then on the assignment today is there's going to be a bunch of the problems mixed together for you to factor. Okay, so you're supposed to follow those steps. Let's look at example C. Factor if possible. 6x squared minus 96. So, step 1. Is there a greatest common factor out of 6x squared and 96? Jared? 6. So I would definitely take a 6 out in front, and what would that leave in the parentheses then? X squared minus 16. Okay, so in the parentheses I have a binomial. Is it a difference of squares? So you ask yourself, is x squared a perfect square? Yes. Is 16 a perfect square? Yes. And is there a minus in the middle? Because if there's not, it won't work. But yes, so we definitely can take it a step further then. 2 sets of parentheses. square root of x squared, x in x, square root of 16, 4 and 4, and remember 1 is plus and 1 is minus. And that's as far as you can go. Always double check though that what's in the parentheses couldn't go to another set of difference of squares. We saw that yesterday. Okay, but those, since they're just x's in there, you're pretty much done. Okay, example D, 16y squared plus 8y minus 15. Are there any greatest common factors in that?
No.
My tree? No. Okay, then we're going to, it's a trinomial, so we're going to ask about perfect squares. So question 1, is the first term a perfect square?
Yes.
Yes. What's its square root?
4.
4y. Question 2, is negative 15 a perfect square?
No.
Definitely not, so that is out. So then we have to go to our last resort, which is 2 sets of parentheses, and this one might be a little interesting for us. We start with 16y squared. We know there's going to be a y in each one of those, but what are the factor pairs of 16 that have to be considered? So 1 times 16, what would be next? 2 times 8, and 4 times 4. And like I have suggested in the past, I would always go with the set of numbers that are closest together first. Doesn't mean it's always going to be that, but that's what I would attempt first. So 4y and 4y. The minus means what? Different signs. So I'm going to put plus minus. And then you ask factor pairs of 15. So 1 and 15 and 3 and 5. So I'm going to try 3 and 5 because they're closest together. Now I have to test my outer negative 20y, my inner positive 12y. When I combine those together, what would it be? Negative 8y. So I'm very close, aren't I? I needed positive 8y. So what am I going to change, Megan? Switch the signs around. So this one is going to be a plus, whereas in front of that 3, that's going to be my minus. So if I did the outer now, it's positive 20y, inner is negative 12y. That would give me positive 8y. Question, Josh?
For like one of those that we just did with it, could there be a prime?
Yeah, they could, yeah. And those are the worst. He asked if that one could be prime like that. Sure, you would have to exhaust every pair, though, and every combination. And that is terrible. Because there are times you have to do that, and none of them work, but you have to go through every set, and then you say it's prime. Megan?
What if it says yes? Like what if it's yes?
Over here on the right, you mean? Then you would put the square root of 15 there, and then you'd go to question 3 and see if that worked. You just keep going with those 3 questions, and if they're all 3 yes, then you would just do your perfect square trinomial factor. Yes?
What would you do if there was not a variable on 16?
Then it wouldn't be this kind of equation. Unless you had the y squared at the end, and then you would just do it in reverse. Okay? And try to change it around if you could. Yes?
So it can't be prime if you factor it by perfect squares?
These could be prime if they're binomials. If number 1, if there's a plus sign in there, that's prime. Or if they're not perfect squares, yes. But if you factor out, this is really important. So listen to me. If you factor out a GCF, you have factored it. So never say after you factored a GCF out and then you can't go further, then don't call that prime. Okay? If you factor out a greatest common factor, then you factored it. If it goes further, great. If it doesn't, you have still factored it. Okay, any other questions? Olivia?
Wait, so, like 16, what if that wasn't able to square it?
If 16 wasn't a perfect square, you mean on that example C, then you would just stop with this part right here. You would just stop with that. It would be 6 times the quantity x squared minus whatever. If it wasn't a perfect square, you'd stop there. But you still would have factored out the 6, okay? All right, I've got to turn this off and start another video.